Hello, I'll be demoing Project 3. This first part, I'm going to show you how the format of the code should look like for your output. And the second part, I'll be explaining the banker's algorithm further to show you the process and logic of this algorithm. So for this first part, it's going to be very similar to your sample output. It'll show this, that, available vector, and the different matrices, and a menu prompt showing one, asking for or checking for a safe sequence, and two, allowing the user to request resources for a specific process. So showing test case 1 is going to try to find a safe state sequence, and in this case, this is that. For your matrices, you can provide it in your code or in a separate text file, however you want to implement your code. It doesn't have to be exact as the sample output. You can add any number you want, but it should all work thoroughly. And just for the sake of grading, make sure there is a safe state sequence available in whatever matrix you develop. And for 2, let's demonstrate that. So you should ask like, oh, what process should we work on? Let's work on 4. What resources do we want? Well, let's give them 331, just like in the example. And it's going to try to see if there is a safe state sequence if we do that. And in this case, there isn't. Now, hopefully this explains well enough what we want in your output, at least how it should look like. Alright, so I'm going to explain further how the banker's algorithm works. So there's the allocation matrix, meaning how many resources has been given to a process. So T3 has been giving 2 resources of type A, 1 of B, 1 of C. For the max, that's how much a process needs in total in order to execute. So for T0, it needs this many resources of those types. And the need is the max minus allocation, because the max is how much it needs in total. Allocate is what it already has, so how much is needed is what is under needed. And for our available, that's how many resources is available to get the ball rolling, to start our executions. For the algorithm, we're going to initialize all these matrices, these vectors, and we're going to check the next available process and see if our available vector is greater than this process's need vector. In this case, it's not, so we can just move on for now. And let's check again. Is our available vector greater than the need vector? Yes, we have more resources available than what's needed. So we can, quote unquote, execute this process, just pretend, and record the process number in our sequence for our output later. And now, since this process doesn't need these resources anymore because it's already executed, we can take those allocated resources for ourselves and add it to the available vector, right? Okay, so now let's move on to the next process. Available is less than the need vector, so we'll just move on and let's check again. Now our available vector once again is greater than the need. So what we're going to do, execute this process, record it in our sequence, then take the allocated resources for that process and give it to ourselves. It is ours for the taking. Great. Now let's move on once again. Check this one. Yes, our available is greater than the need vector. So we're going to process, add the resources available, or add the resources that were allocated to our own available vector, record the process that was just executed in our sequence. Let's move on to the next process. And we're going to loop back to process 0. And now this time we do have more available resources than what is needed. So let's execute this process, record it, and add the resources that were given to it for ourselves and move on to our final or the next process that hasn't been executed yet, which still happens to be the final one. And we finally do have more available resources than what is needed. So we're going to execute, record it in our thing here, add whatever was in here to whatever was in our process to our vector, and that is the banker's algorithm finding a safe state sequence. That is your test case 1, all done. Now let's go further into test case 2, requesting specific resources for a specific process. Well, in our sample, we asked for process 4 to get these resources, right? 3, 3, 1. Now, to show you what we mean by that, well, if you can remember, one second, what was available to us was this many resources, right? And we're requesting this much for process 4. Now, the available is less than what's needed. And let's see why that's a problem. Well, we're going to give these resources to process 4 like the user asked, and so let's do some math here. Let's see. So 4 minus 3 is 1. 3 minus 3 is 0. 1 minus 1 is 1. So this is how much that vector still needs. It still needs one more of this type. And now what's available, we used all of this. So let's do some math again. And 3 minus 3 is 0. 3 minus 3 is 0. 2 minus 1 is 1. So to recap, we had this. We started out with this much. We wanted to give this much to process 4, and we did. And we're left with only this much, right? And the process hasn't even been executed properly. It still needs more resources. That means we can't get what was allocated to it. All right, so what are we going to do? Well, all we can do is we should check the next available process to see if we can execute it, and then we can get its allocated resources. And we're going to look through all these processes and realize we can't. We don't have enough available resources anymore to execute any of these processes, meaning this is an unsafe state because we gave our resources too early to a different process that we couldn't fulfill, and we just simply ran out of resources. That's why this is an unsafe state. Hopefully I explained thoroughly enough what this banker algorithm is. If you have any more questions, ask in the comments, ask your discords, because if you have a question, there's a chance that someone else in your class does too, so it doesn't hurt to ask around. Anyway, have a great day and good luck.